Kristian, can you make that fantastic presentation that I saw you do? And I'm not going to use the word dumb it down, but make it so that us in the library could use it, perhaps, to make our data visualized. And Kristian said yes, he would do it. So here's Kristian Allen here to help us in the library world. And did I throw enough stress on you to maybe put this out? And hopefully we're broadcasting it. But if not, let's just run.
Yeah, it sounds like everything's okay with broadcasting. And I have everything, everything you see here, and for those who are listening, everything you see is online, and this is the second variation of this presentation. So I have all the source materials, and so don't worry about taking notes. They're all available. So like Sharon mentioned, my name is Kristian Allen. I'm a developer with the digital libraries here. I'm a programmer, primarily working on web applications. And one of the areas of interest that we're looking to move into a lot more at the digital library is data visualization in general. So with our collections, we view data visualization as a way to engage our users and to explore our content a little bit easier, and to uncover new and interesting pieces of data, stuff that you wouldn't traditionally maybe run across just doing the traditional search, the Google search bar. But if maybe you had items plotted on a map, or you had a heat map or a network graph of maybe Library of Congress subject headings, and how these pieces interact with each other, we think that would be really interesting to draw users into our content. And then looking farther down the line, what we hope to do is engage our users to add their own metadata, and this is valuable as well, and use this in data visualizations. So the most basic level, see something on Facebook or Pinterest or something like that, we could keep track of how many things get pinned or liked, and it would be interesting to graph those and see where the interest in our collections vary. So what I hope to show today was just some existing visualizations that I think are sort of flagship visualizations that are common out there that you may have seen before, but maybe just walk through some of the technology they used and the tools. And we'll look at some of the different tools that they use to create these that we could use. What's some low-hanging fruit that if we just have a text file or a spreadsheet, that we tweak and we play around with for an hour or two, what can we do with that? And then we'll create some, and so to illustrate that, we'll do a demo with some Google tools and some World Health Organization data. And I also cleaned up, Sharon was kind enough to send us some gate data from the music library, and so I cleaned that up a little bit, and we'll suck that in and just poke around at it and see if we can make some interesting visualizations with that. And if there's any questions, feel free just to stop me at any time, and if something's unclear, or you have, if you want me to talk about something a little bit more, just let me know. So I think everybody knows there's a high demand for data visualization. If you go to New York Times or any of the large the Huffington Post or any of the large media organizations, a quick way to present a lot of data quickly that's eye-catching is a nice map or a nice graph, something like that. But it's not just eye candy. I think it really allows you, by presenting it visually with different statistical values and analysis, your users actually become participants in the data. So it's no longer, I think the big shift is it's no longer static content. It's you're really engaging your users, and rather than having something flat, like this is all data from 1950 to 2000, that's all you get. Now they can shift and filter and sort the data and really pick apart what they're interested in. And knowledge increases through this. Maybe you'll recognize things that you wouldn't otherwise. And we have a couple of some of the our sysadmin team here, and so I've been talking mainly about the digital library and digital assets and things like that, but also I think I'll show a really couple cool examples of just log files, so basic log files for web servers, which seem like would be extremely boring, can be really some really impressive visualizations can be generated from that, and just seeing the data in a different way maybe allows you to recognize something quicker than you would just staring at a text file. So we'll look at some of the classic visualizations that are out there that you may have already seen some of these. I hope the first one I think you've probably seen before. The second two I think are fairly new and I think are pretty cool, and we'll look at. So the Social Security Administration generates a file every year, a huge file of the most popular names in the U.S., and they've kept this back to the late 1800s. So Sharon sent out a pretty cool blurb, I thought, in kind of the teaser for this visualization. Like, so if you were going to pick a virtual librarian, or you're going to pick a name for someone that you want to represent, say a virtual service or something like that, Sally, Jim, or something like that, this would be a way to just quickly identify, you know, the average student age in that comes to the desk is between 18 and 20. So let's check what the most popular name was 20 years ago, and we'll name that to identify something that would just your students would identify with quickly. And this is a good example of just drilling down through almost 1 million records, you know, almost instantaneously. So this data is all the way back to the 1800s, and the actual text file is gigantic. And so there's some merging and things like that, and that needs to be done, and some custom programming for this, but it's just an idea of what's possible. And so as you type a letter, the data shifts dynamically to represent, and you can see just over the course of time what names were popular and how they moved and what rank they were, and so it's fun just to drill down to see with how the naming changed. And so to illustrate that fact, if we want, someone actually took the top names, and this would be, and generated just sort of an animation through time, what the most popular name in for boys and girls. And so this is something that, so you look back, okay, the average age of my students are, so maybe they know a lot of Lisa's or Emily's or whatever. And also, I thought this was interesting. What this is an example of just really basic geospatial data. And what I found fascinating about this that I would never guess is, you know, traditionally for various reasons, we tend to think that the coasts of the United States tend to set trends, California, New York. And if you watch here, it's really interesting that the South and the Midwest, the most popular name usually pops up there first, and then it gets distributed throughout the rest of the country. So I think you'll see, like, so here Jessica and Ashley and Hannah start in like Tennessee and Alabama, and then actually spread out through the rest of the country. And so this is something that you wouldn't get from a text file, and this really isn't that. We'll do this with the world, or we'll do something very similar with the World Health Organization data really quickly. Like just plotting things on a map can really open up some really interesting introspective details. And then, so this one was, this is for the sysadmins. There is, this is actually real-time data of cyber attacks that are happening right now, and so it's a little dark, but and this is off the corner. But again, I have the URL, but you can actually see. Oh, thank you, Sharon. Yes.
Start from China.
Right. Yeah, you can see where they most generate from. So. So where this was really fascinating was for in the computer side of things. Recently, there was we in the library use a popular software package called Drupal, which is the content management system. And recently, there was a large security hole announced for that. And so I brought this up that morning, and you could see, Target not actively attacking us, but you could see where attacks had increased because they were looking to exploit this high-profile bug. And there was another bug called Heartbleed a few months back, which was the same case. So if you read about a cyber attack in the news or something like that, it's interesting just to pull up this map and see if it's increased or there's any activity. This is actually fairly tame for today. So interesting.
Okay. I was just going to say, I wasn't doing something out of the United States.
Yeah, no, we're pretty. Usually, I mean, this is. I guess just, I don't know. For some reason, they tend to come from Eastern Europe a lot and China. So. And this is also another instance of making boring data really interesting. So as part of the development process, software engineers use something called source control, which essentially is just tracking their files in a central repository. So you can always go back to a particular version, you can change a version and do some testing on it. And a popular online tool for that is GitHub, where it's a community repository essentially where people write code and donate it or fix other people's code and other open source software projects. And in the library, we contribute to GitHub, and we contribute to several projects on there. And you can type in a username and actually get a visual representation of the types of projects they work on, the types of languages. My information is fairly boring, so we have another developer here who has worked on several different projects in the community, Kevin Clark, and he's worked in a couple different parts of the country. So it's I was just going to use his username as an example of just come up here. So it's a little confusing, but you can see for the actual languages that they work on are down here. Related projects are grouped together in a certain way. You can actually drill down into the project and see the daily commits and the actual different pieces that they worked on. So for, again, repository data is something I consider analogous to maybe certain pieces of like check-in, check-out data of books. It doesn't seem particularly interesting on the surface, but if you really dig at it and pick apart with it, you can really generate some really interesting things. So I think it would take a little custom programming work, but imagine if we had, if we took our check-in, check-out data of different books or laptops or things like that, and we grouped it together by different subject headings, and maybe we would uncover some different interesting trends, like these books tend to get checked out together for whatever reason, stuff that you wouldn't be able to anticipate, and we can better serve our users by maybe reorganizing stacks, or someone who checks out these magazines tends to also get these as well. And it was also help a reference librarian as well, just drawing some different trends, like, oh, this is interesting, why is this? They tend to get this art book with this history book, and maybe after speaking with patrons or students, it turns out there's a class that uses those or something like that. The idea is just you don't know what you're going to stumble into. And so the next thing is I thought this was really interesting was you can not only, so we talked about these are really pretty to look at, and what if we took it to the next level and we actually were able to physically engage our users using this content? And so one very a fairly basic interesting visualization is called Listen to Wikipedia, and this is on GitHub. This is open source, and this source data is available. And if I turn up the volume here, basically different chimes and pitches. These are real-time Wikipedia edits, and you see the editor, and depending on the size of the circle, actually represents the actual magnitude of the edit, how many paragraphs and things like that. And so this can actually be changed to use with a lot of different data sources. So any data source, really, if you can just parse it into its particular parts, which is essentially an event, something associated with it. So people have changed this to work with Bitcoin purchases and other publicly available sources of data. And I talked with Jonathan Wilson, who is one of our techs here at the library, and I showed him okay, so that's Roman Catholicism in Guatemala had a big edit. And I think a good example, really one of the organizations that I view as really a flagship organization in some of the work they do is the North Carolina State Library, and they took Listen to Wikipedia and they modified it a little bit, tweaked it, and actually we could use this to only represent Wikipedia edits related to UCLA. We could do a lot just to draw in students, or put Wikipedia is related to news events and things like that. And so this is all already available. Open source is just it would require a little more tweaking, but this is just some of the types of things that you could do. And then one more. This is one more example of just something that's usually fairly boring. These are log files, and this is an actual representation of a hacking attack on an organization. Looks a little bit like something like that. So where this would we thought so you can also focus on the library data, just in general, where they're coming from. We were looking to use this with some of our collection. So one of our Green Movement collections having to do with data collected in Iran. We actually have the log files from the web servers, and they were being hacked by adversary groups. So it'd be interesting to actually use the library to visually represent how these groups were attacked over time, and have a little more interesting way to browse the material. And finally, this is another real quick one. This is just a popular tool that's used is D3 for visualization. So I should say I should back up just a little bit. The easiest way when you're trying to convey something or thinking of a visualization, I find it helps is just to find someone else who does something close and copy that, or tweak it a little bit for our uses. Or if you read an article in the New York Times and they use an interesting visualization, this will spur an idea like, hey, maybe I could use this for my data. And so this is just a repository of various different graphs and network charts, maybe that you wouldn't be aware of, that you could use in different manners. So it'd be just like looking, oh, I have, if you can think about your data just in a slightly abstract way, you can repurpose a lot of these. So an example would be, actually, I can show right now an example of how we repurpose one of these right now. So this, on its surface, doesn't look too exciting. It's a hierarchical representation of data. You know, this is actually a visual representation of a software library package. So you have the parent package, you have the child package, and you have the leaf nodes that keep going off of it, and you could drill down into it. So from a, you know, from my point, like from a nerdy point of view, it's like, oh, this is awesome. I can dig into the documentation a lot quicker than just flipping through a manual. And we worked with a contractor to actually switch this to be used with Los Angeles photograph data. So there's also hierarchical data of dates, and this is using that same, a modified version of that code, but it's the same concept where we have a digital object and there's a certain hierarchy that we drew out of the data. So in this case, it was, you can drill down into the date. Let's see, so, and then under the date, you have various topics, and then once you get down to the topic level, you have actual digital item. And so this is something that maybe this isn't advanced enough that a scholar would use it, but the idea would be this is great to engage users and just get people who would maybe never even look at photographs from 1930, but it's fun just to poke around and see what's in there. Okay, so finally, okay, so we've seen lots of good stuff. Great. So how do we even get started? You know, how do I do all this cool stuff? So by far, you know, the initial challenge is organizing your data, and this is often a lot of work. So if you already have your data in a spreadsheet, normalized to a certain extent, or to some type of naming conventions or things like that, that's a huge advantage. So a lot of different tools on the web expect different formats. And if you're usually safe with a CSV or a spreadsheet file, if you already have your data in that format, that's phenomenal. That's great. And the ability to convert to different forms is valuable. So on the web, the most popular form, or one of the most popular formats, is JSON. And so a lot of the examples that we looked at are fed by data in a JSON format, which is just a text file. It's basically, you can think of it as a lightweight version of XML. So it's a giant text file. And so there are tools out there that you can convert. You just feed it in your spreadsheet, and you can convert it to these different styles. We really don't have time to go through these. They really almost have it would be great to have their own workshop on their own to get some of the data from you guys, and we could actually work on a particular use case. But so for basic cases, if you just have a spreadsheet and you just want to convert it to JSON format, or you want to tweak it a little bit, there's an online tool called Mr. Data Converter where you just upload your data and you click a few buttons and change things. And then inevitably you're going to hit the hump where you have exhausted sort of the low-hanging fruit, and you need something with some more industrial strength. And there's a tool called Google Refine, which is kind of Excel on steroids, really. You can do a lot of custom programming to it. You can do a lot of mapping. You can do a lot of tweaking to the data. So this would be a tool that if you have really dirty data that you need to change or tweak, that's something I'd look into. And we've done an intro workshop onto that and into that, and it really it's really worth investigating if you have a huge amount of data that you need to change or alter the format. And so what I mean by that is, like, in the most basic case would be something like, in the initial spreadsheet, we spelled a word wrong, so just do a search and replace on all these. But if it's Tuesday, don't change the spelling, because for whatever reason that's the spelling on that day or something like that. So if it's a little more advanced, then search and replace, Google Refine is a great tool. So this sort of just outlines we saw some very complex data visualizations, and a lot of those are custom built for the interfaces. So, so for stuff that's as complicated as something like a hacking attack graph, we're not going to be able to just drop our data in and just have it work. That required a lot of massaging the data and a lot of custom programming. So in general, this is the complexity stack that you start out with, and the tools that you'll need going forward. So if you have your data it's just in the starting format is just a simple text format or plain text file or a CSV, and you can use a lot of off-the-shelf tools that we'll be looking at today. Then the next step, to use some of the slightly more advanced visualizations that we looked at today, you'll need JSON or XML format. And then as your data size increases, you'll reach the limits of a text file. Your text file becomes so huge that you can't pull it all. The computer can't deal with all that information at one point. And so at that point, you really have to. So for an example of that is for the LA Times data that we just showed with the collapsible icicle chart. We pull our data dynamically from a database to assemble these different pieces, because we have so many records that we can't pull them all at once. It wouldn't be a very good user experience. We can't pull them all at once to assemble things. So if you have huge amounts of data, and so this would be like scientific data or something like that, you may have to tweak it a little bit, or just use a couple extra tools to be able to parse it out a little bit more effectively. And then for industrial, like this is like industrial strength, huge, tens of millions of rows. If you're a hedge fund, or you're some kind of, you're dealing with a lot of health data or something like that, there's very specific tools called Hadoop and MongoDB and a few others. Oracle as well will deal with some of this. That if you reach the limits of that, then there's some extra tools to deal with some of those. So you may read in the news about Hadoop. That's a popular one that Google uses a lot, or Facebook, just to track trends among the different users that use their products. So we're going to start with Google Charts. We're going to play around with that a little bit. We're going to just suck in some spreadsheet data, and we'll post a map, and we'll publish this to the web. And then as a bonus, what we'll do this with some World Health Organization data that we just downloaded, which is a standard spreadsheet, and you can think of it as it's just in the abstract sense, you can think of it as data that you had, and then we also have a geographic point associated with it. So the point is, I guess, even if you're not interested in World Health data, if you have data that's associated with some geographic point, you can do this really easily with that. So in this case, their use cases is World Health Organization data with hepatitis B, immunization rates for infants, and so we're just going to use a spreadsheet. We're going to import it into a tool called Google Fusion Tables. We're going to create a map. We'll publish that on the web, and then we'll extract that data and we'll use it in Google Earth. So we'll present this on the web just in a flat map, and then the bonus we get is by importing it into Google Earth, we can get a 3D representation of this. And this can also think of it. I don't have the example with me, but we did this with where this, just for ideas of data we have is, so we have LA Times data, and we have the coordinates associated with that, and we would plot that on a map, suck that down to Google Earth, and now in addition to just seeing on a map, you see this 3D representation of it. So you can superimpose the photograph against buildings and things like that. So it opens up a lot of options. And I have I'm going to walk through this, fairly quickly, but I have this all in a step-to-step how-to. So if you wanted to replicate it at home with the same data, it's really easy to do that. And so this is just what we're going to be going through. This is the document I have outlined, and I'll send it. I can get everybody's email addresses, and I'll give this out, and I can send you this. But we'll just be walking through this example. And the caveat is you have to. I think everybody usually probably has one. But you have to have a Google account to do this. So under Google Drive. If you just go down to more, you'll see a few different options, and there's sure. I'm sorry. This guy is really delicate, so I just want to make sure I don't yank it out of here. Okay, can you guys see that? Okay, my bad. Oh right. So under in the corner, there's an option new, and under new, there's an option more, and we're going to be choosing Google Fusion Tables. And the first thing that comes up is a couple different options that you can upload a spreadsheet from your computer. You can use an existing spreadsheet, or you can create a brand new one. So in our case, and just an example, the most common example you guys may be working with starting off is you just have a spreadsheet on your desktop. And so the idea is just to play. It's a really low effort, least expensive way just to play around with some data for a few minutes and see if you can coax something interesting out of it. So the first thing when you upload, the first thing you see is just a preview of what, and the idea is just any red flags to point out if your data uploads and it's just gibberish or doesn't come up. This is just a preview of what you have. And a caveat is the way Google Fusion Charts works now is you can only work with one data sheet at a time. So that's a limitation. So it's just something. So for one of the so this is an example of where you may have to tweak your data a little bit to work with some of the existing tools. So just as an example, the music library had their data broken up by month into individual into individual sheets for each month, the data. And so I just had to merge that into one data sheet to work with this. So there's not just, we can, for our case, we can just accept all the defaults, but you could actually put some security settings on here if you don't want users to download your data. So right now we have nothing, there's nothing exciting. We have, everything is now uploaded to Google. So it generates a few, it just makes some educated guesses and tries to generate a few infographics out of the box. And so it noticed that we have something that looks like a country or a region, so it generated a map for us. And we'll need to clarify in particular what location we are. So we're going to choose under the location. We'll tell it specifically use the country column. And so in order to plot data on a map, mapping tools usually need the Latin long. They need to be generated this from somewhere. And so in this case, Google is actually geoencoding it for us. It'll take its best guess at the Latin long and use those. This isn't going to be perfect for auto generation from Google. So if you're really particular about this, this is something to keep in mind, and we'll see some obvious examples where it messes up in this case. So this is world data, and Georgia is a country, and it's also a state in the U.S. Google doesn't know which one you want when you're referring it to it, so we'll see. It just puts it in both places in this case, but so that's just something to keep in mind.
So I have a data set that has city and state data.
Okay.
There's Portland, Oregon, Portland, Maine. Can you pull from, I know it's parsed out by columns, in separate columns. Can you ask it to pull from 2 columns?
Yeah. Yeah, so you absolutely. So you can, yeah, so you're fine in that case. You can merge the 2 columns together and pull it in. So and in this case, there's some additional just like tweaks that we'd have to do, but we could specify this is only country data. So in your case, you say, oh, this is just U.S. Yeah, exactly.
Can you use like geocodes or like identifiers that are used in the data to distinguish between like the different Portlands and use those to generate this?
So that's a good question. I'm not sure. You can give it like a lat long, but you would give it like a linked data, like a
Because I would expect that, given the geonames, I imagine that these identifiers are also linked to their latitude.
Yeah, no, that's a good question. So my initial, just thinking off the top of my head, is my guess is Google won't do that out of the box for you, but there would be another quick tool that you could run just to update your spreadsheet with the lat long. So there has to be a tool out there that you could run. And so in that case, I would just see if I could update the source data and then upload that data if you're looking to use it. And so that must be available. I'd have to just dig around with it. That's a great question, though. So it takes a little while to crunch through this, and then we see these basically just plotted on a map. So this is a quick way. Oh, and this. So we'll narrow, and we have a bunch of options to filter the. So in the top left-hand corner is actually a filter that you can edit based on the columns. So I was just going to show an example of narrowing this down by a year. Okay. Thank you. So it's a little skewed. So then we have a whole bunch of data, and we can just narrow this down by a yearly range if we want to, or we can tweak a bunch of these. Any of the columns you could actually set values on to tweak.
Sure, I think the legs of the cart are blocking the edge a little bit. Maybe the whole.
How would you fix it, Brooke?
I was just saying, slide this thing further forward on the cart because you see the lights being blocked here.
Yeah.
I'm just saying if you push this a little bit further forward, then I don't know, then still probably move it around to get that.
Right.
But at least now you don't have.
Right.
You know, you don't have the,
No worries. So and so so the
Just a reminder that your visualization can be awesome sauce, but if your projections.
yeah. So in this case, you pull it. So if you had data, you could pull this up. Like so, for the great example, for a class or something like that, or if you're doing some homework or something, you can just plot this up, and it's a good, easy way to get data up quickly. And you can share this with others. I could post this publicly. You can change these little info bubbles to have a little thumbnail or any types of data, or make in the example. We're running a little short on time, so the example I did is I actually. You can tweak these to change by percentile value. So I just had anything below 25% make red or yellow or green. So you can play around with these and change the info bubbles based on that. So there's a lot you can do with not a lot of effort. And I haven't played with this. This is new since I gave the last presentation. But there's actually an out-of-the-box heat map now. So I think this would be really interesting to play around with. Different settings to, so in this case, maybe tracking outbreaks or something like that. It seems like, this particular, it may not work for this particular use case, but So for example, for our case, I think it would be really cool to get all the gate data of the UCLA libraries and then map a heat map, and see like, okay, where are the most popular ones and things like that. So is there a trend, or see the different libraries clustered together or something like that. So there's a bunch of different options here. Finally, let me do this real quick, and then we'll upload some other data, and then we'll have some time for questions. There's an option under File, which is over here again, cut off, of course. Under Download, you can download a KML file, which is just a particular way to encode geospatial data. And once we download that, you can actually open this up in Google Earth, and then, so this is the same data that we're looking at. So we haven't tweaked it. We haven't made any changes to it. Just make the markers a little bit bigger. So this is just, now it's represented on a globe. So this isn't that exciting, but you can it's just another different way of viewing the data. You can play around a couple different tweaks with it. We did some examples is we actually did the street view of like mapping pictures over time, so you can superimpose something, kind of a poor man's version of History Pin, which is sort of a site that you can upload something and superimpose it over the Street View, Google Street View, so you can see how photographs change over time. In this case, maybe you want to represent something in a 3D way, but I guess the point is you get this for free. You can just export it, and we did this in 10 minutes without a lot of effort. Yes.
Is it any limit on variables for this kind of display visualization?
Yeah, I think there's I think you're limited. You are limited to the size of the rows, and I think it's something like 200,000 rows and maybe 256 columns. I'd have to double check. There are some limitations, but I think the rows is a little tight. So you would easily go. I could see you could easily spill over that if you have large scientific data. And that it's the standard Excel, like the Excel limitation is 65,000. So if you can fit it in Excel, you can most likely fit it in Google Fusion tables. So we looked at just publishing these geospatially, but now we'll look at what if there's different, what are the charts that we get for free with this, and we'll upload just some traditional spreadsheet data from the music library to try that out. You know what? I'll create a brand new. So this is the same thing. We're going to create a new. We're going to go through the same interface. This time we'll grab some of the library music stats, and we'll upload this. And so we don't have a map here because there's no geospatial data. So we'll look at a different interface that's available is the add chart interface. And so again, don't freak out. They're like, what are these numbers? Google immediately just makes its best guess to show you something, which I think is good because I know just looking at a blank page is kind of intimidating for me. So it's nice just to be, okay, I got some data. Let's just click some stuff and see what happens and go from there. So on the left, so this is the most interesting part. On the left, you have a list of all the different canned charts you have. So you have an area chart, bubble charts, pie charts, and network charts for RDF data, which is really interesting. Yeah, so in this case, the data doesn't actually have a year associated with it in the source data.
It's assuming the current year.
Yeah, exactly. So Google thinks it's smart. This is an example where the actual data is just January without a date associated with it. So Google thinks it's smart and just goes, okay, well, I don't know what year it is. So in order to plot this, I'm just going to guess it's this year. So this is something that you'd have to tweak a little bit, to an example of where, okay, we got the data in there. It's not exactly what we want, but we need to tweak it a little bit. And you can choose the X and Y axis. You can represent it in different charts or a pie chart. I didn't have time to do this, but I wanted to get a breakdown of the day of the week. So what's the representation of which Fridays do most people come to? Which is it Monday, Tuesday? What's the most popular day? So basically the pieces are there. You just have to play around with some of these variables a little bit, and some of the more advanced graphs are a network chart. So you can, if you have linked data or a relationship within your data, you can specify this. You can specify the relationship between different columns and things like that, and expose some content. So a good example of this that someone did recently was just they took, I think, all the characters from the Lord of the Rings book, and what scenes they appeared in together, things like that, and then you would have a network graph, and that was all just based on a spreadsheet. There's no fancy data. So really, just organizing your data is the biggest challenge. So I want to. So we're going to wrap up about the bottom of the hour, and there's about 4 or 5 minutes left. So I just wanted to open it up to questions, make sure I covered things that you guys were interested. If there are other areas you were interested in, go ahead.
Right. I have a lot of students coming with ready data sets, and they said, yeah, I want to present nicely. The only software I know is ArcGIS.
Right.
In this case, you don't have geography-related stuff, so it's not when you will use it. What software would you recommend for ASIS?
So I think I have. So you're right. ArcGIS is industrial strength. That's and it's overkill for a lot of needs. Something that I'd like to have a workshop on. I don't know it well enough yet. I think is Tableau, which is free for academic use, and it's also free in the cloud, and this is very popular in industry and people doing charts, and it's a little more advanced than Google, just plotting things on a map to do different stuff.
Maybe we could do a workshop on how to use it.
Yeah, exactly. So what I think the next step would be, what I think would be a great, so the short answer is Tableau seems to be the most popular, that has the most traction. It's not open source. It's not free for like for commercial use, but it's free for academic use and it's free for personal use. So I guess my point is it's definitely a tool we worth for students to explore because they will use it when they go into industry as well. And I'd be very interested in working with you to do a workshop on that because we'd like to use it in the digital library as well. So probably the best thing would be to get some sample data sets from the students and what they're trying to achieve, and then we can work it out beforehand and then present how we did that. So yeah, I looked at this briefly for this presentation, and there's a bit of a learning curve. It's just more than, so Google Charts essentially just uploads some stuff and point and click. We walk through it, and you can walk through it in 20 minutes and know 80% of it. This is slightly more advanced. I think it would require just a little bit of time, so we'd probably just have a 2-part workshop on it and make sure we have a really locked down use case that we want to use. So get a nice clean library set of data, and then choose a goal, and then see what we can come up with. Were there any other questions?
I have a simple one.
Sure.
So I was trying to follow along on Google, and when I went to create looking for fusion tables, it doesn't have it. So I clicked on something, and it wanted me. So I searched, and I found fusion tables, and it asked me to connect it to the app. That didn't seem like the same way you were doing it.
Yeah. So it should be if you go to Google Drive, and under New, which is cut off in the top left-hand corner, there's a More down on the bottom, and does it come up under More for you?
No, I must have a different version. Mine just
Okay.
when I go to Google, it says Drive, it says Create, and then when I go to More, it says Online and All Items. It just looks different.
Okay. Well, I'll pop over there.
A while ago. I mean, it's a while ago.
Yeah.
You had to switch to the new.
Yeah, that may be.
That was a while ago.
So I'll just stop over after this, and we'll figure it out. It's just Google's they A/B test, and it's sometimes I'll go and it's different, from one spot to another. So.
I remember having more, and now I don't.
Okay, so we're at the bottom of the hour. I just asked if there was any questions from our web audience. Sure.
I use this table fusion in displaying, actually presenting access to sample maps.
Okay.
And it's included in my research guide.
Okay.
But the table map is working perfectly. The table doesn't move, and it's stuck. And this table has location exactly because we don't own all the sun.
Okay.
So is it I'm doing something wrong? Research guide software is not supporting this?
So the question is, why can't you move the actual table data on this? Is it the screen or like downloading it or?
It's a screen.
Okay.
That's what
Maybe we can walk through an example. So this would be your data, and is the issue that I guess I'm trying to figure out. So what is the
when you go to research guide.
Okay.
And when you click on charts that display some maps and locations.
Okay.
The table that is attached to the map, it doesn't display properly.
Oh, okay. I see. So this I'd have to look into a little bit. I'm guessing that it's displayed like in a frame in the research guides or something like that, and it's interacting with other pieces of our data. So I think if I just sit down and walk through an example with them, I'm guessing that it's something that on our site is probably in a frame or something like that.
That's what I'm guessing. Yeah. I'd like to actually look at
Yeah, I mean we can take a look at it right now. So.
You know, one thing I'd like to bring up is maybe throughout the library, an effort to, when we make an effort to gather data, to look at standardizing it so that we all are aware of here are all the efforts to gather data, and making it easier to make it easy to visualize it. Does that make sense? So that we're aware that we are all gathering gate counts, that this library isn't collecting only these fields and making it difficult to compare the fields with this library.
Yeah, so this is a great example where I think it would just take maybe a little committee or somebody, people agreeing. I think it would be cool to have, and I don't think it would take much work. It just basically, a library data repository.
A standardization.
Yeah, exactly. And we just, right, because, that is a challenge. It would be similar to like, a public data set or something like that you would just make it available. And, maybe we don't do something with it, but someone else in the library wants to do it there, play it. You can be assured that it's always going to be in this format. It's these versions. It's
easy to compare.
Yeah, exactly.
Easy to visualize.
Right.
Because when I went around trying to gather all the turnstile counts, they were crazy different. I'm going to collect it in fiscal year.
Right, exactly.
I'm going to label this different column, and I'm going to put it in this crazy. It was just amazingly different.
Right.
No standardization.
Yeah, no, that's a great.
Across all the different libraries.
Yeah, exactly. I think that's a great point. So I think the easiest way to move forward with that would be just to pick a small data set project and then work with that and then work backwards to the larger ones. And maybe gate count is. Where do they pull the stats from? Is it just like someone actually gets the physical, writes it in the physical
that's
from?
What they do.
Okay. So that wouldn't be too bad. We just get everybody to agree, hey, and so I noticed on the spreadsheets, like a lot of calculations were done in there, people per hour and totals and things like that. And we can calculate all that for you. So the only thing you should have to do is just, basically we just need the date and the count, and we can figure, and the time, and we can figure everything else. Although, yeah, I don't know how. Yeah, it always gets a little tricky. But I'd be interested to see how that data is gathered, and I'm sure we could clean it up. Okay, well, thanks, guys. I really appreciate you coming. And
I like that.
Do you want to the information?
Oh, yes.
Kristian was